We're going to go through several different areas. We're going to see food production. What do shellfish eat? Carrots and peas? Probably not. But we're going to see food production. I'll talk a little more about that in there because they eat a lot of food. We're going to see about one of the life cycles of the clams, oysters, mussels, geoducks that we grow here is the larvae stage. We're going to talk about a little bit about the larvae. We're going to talk about the seed. A seed that's not swimming anymore. We'll talk about, and I'll show you some of the seed also, some of the small geoducks and oysters, and even having a little abalone inside here. And show you some of that. And we also do a lot of research in the building here. And Jared, who's the other guy down here, is actually working in a research area, and he's going to talk a little more about that. But I'll point out some of the things in there. It really depends on what you want to see. If you got questions, just ask right away. If I don't know the answer, I'll just have somebody else answer that for me. So having said that, let's go in. We're going to go walk straight through the building and go to the far side over there. And then they're working over there doing different things. So I'll try to stay out of the way the best we can. And we're going to talk about algae first. And so that's all I'm going to leave it right now. We'll go in and we'll talk about the algae. And then, so just follow me and we'll go all the way through the building here. Watch your step. Now, one of the things we do here in the hatchery is we grow a lot of food. The shellfish, the adults, oysters and clams eat a lot of food. The seed, the small seed we grow about this big, eats a lot of food. And the larvae that's so small we can't even see it with our eyes eat a lot of food. One second. And so we grow a lot of food. And the food they eat, obviously, is not peas and potatoes. It's algae. What you see here in the bags is different species of algae, single-celled algae. It's like it's swimming around the bay out there, only we have it much more concentrated in these bags here. And this is one way of growing algae. In the top of this bag, there's some pasteurized seawater coming in. Well, whatever comes in has to come out. But what's going on inside here? Well, the algae cells are actually dividing. They're growing all the time. We have natural light, and we have artificial light back behind here. And they have the pasteurized seawater, so it's sterile, and that allows the algae cells to divide and divide and divide. So again, the cell density, how many cells there are in a certain volume there stays about the same. The different colors you see here are different species. But you also might see a coffee versus a light tea color. It's an identical species. It's just a different number of cells, algae cells in that bag. You have a question back here? That's another type of algae. It's the same thing. It's a single-celled algae, but that one's called plat pea. It's our nickname for it. And but again, it's a totally different species. We grow different species because they have different nutritional values. You had a question over here first, sorry. You had a question first. Moon snails. Question was, do we have any moon snails here? There are a lot of moon snails that grow out in the bay out here, but there's not much of a market for moon snails. There actually is a little market for them. The company does take them off some of their beaches, but we don't commercially try to grow them. Any other questions before we move on here? Yes?
How did it get like that?
We barely started talking about the algae. So, and I'll answer that question as we go on through here. The question is basically, how did we get to this point? You see some empty bags over here. Let's back up a little bit on the algae. When we want to get an algae start a bag, what do we do? Where do we go? Initially, if we first start the hatchery up, where do we go? There's two things we can do. We can go in the bay out front here. We can actually isolate different types of algae using a microscope. We'll pull single cells out of that culture and grow them up in I'll show you a little flash from back here. And that's one way. The other way is we'll get on the telephone or the computer and we'll call up a lab somewhere. One we use is actually in Maine. It's called Bigelow Labs. And they have this whole big phytoplankton area, algae area, and they produce thousands and thousands of species of algae from around the world. And we'll call up and we'll order a little start. It costs me about $130 for a little vial. Looks like clear water. But there's algae cells in there. And then we'll start that in a little flask room. One second. And we'll go from a little tiny vial like this to a bigger flask, to a bigger one, to a carboy, to a bigger tank like this. As it's growing all the time. Where are all the animals? We're going to see animals here shortly. We're going to go talk about the algae first. Then we're going to go on the other side of the building over here, talk about more of the larvae, and you'll see some of the animals. I have some set out for us to take a look at.
Okay.
Question?
Will there be all different kinds of animals?
We're going to see, what are we going to see today? We're going to see some geoducks. We're going to see some Pacific oysters, some Olympia oysters, some no jellyfish,
Yeah.
some abalone, some sea urchins, some scallops, some mussels, some manila clams, and that's about it. You guys are full of questions, yes.
The gooey's escort us.
If I talk to them nice, they will.
Oh.
Yes.
I want to see the squirter. Did you guys get the water?
Right, we haven't talked about the mechanics of the building yet, but we have pumps down by the high tide line down on the lawn down here. We have several pumps. We can pump from different areas of the bay, from really shallow water to very deep water. The water that's coming into here comes from very deep, it's 110 feet deep. It comes from the 110 feet through some 6-inch pipes into a pump, into a big filter house outside I can show you, in through a bunch more filters, through a heat exchanger to warm it up, through a pasteurizer, pasteurize it, through another heat exchanger to cool it back down again. Nutrients are added. Then it comes through these glass lines to go into this bag. The reason these lines are glass, and this is silicone tubing, is so it can take extreme heat, because once a week, actually today, we stop the flow of this water for a few hours. We run steam through these lines, keep them clean. Because these are not bacteria free, but they're limited quantities of bacteria, and we want to keep them as clean as we possibly can. And some of these algae, especially that one, the green one behind you there, that plat pea, likes to stick to things. You see how it's sticking to the top of the bag over there? And it'll stick in the lines there too. We always try to run steam through these lines to keep them clean. And so the algae, think of that algae as kind of like a sourdough starter. You're probably familiar with a sourdough starter, how you always take one start to start another start. The same thing for the algae. When we start a 4-liter flask about this big, we always take a little pipette, a little tube, and start another flask up. And we'll keep the cultures going for a long time that way. We're going to one more stop into the building here, talk a little more about algae, and then we'll work on our way outside the building there. Oh, while we're standing here, you see that fresh water, this water dripping down here? All that is fresh water. Anybody have a clue why we're dropping fresh water down these bags? It's seawater inside. Why would we want fresh water outside the bags? It's cold fresh water. And these bags get pretty darn warm. They have warm air bubbling into them. They have warm lights behind them. The building gets warm. So all we're doing is a little valve kicks on back there when the temperature gets too warm, opens up the fresh water valve, it dribbles fresh water down there. And as that evaporates, it cools those bags down. Let's crowd on down this way. Here's an old bag here we pulled out. See some of the junk inside of it there? It's just old algae. As you guys walk by, take a look at the flask right here. This is how we're starting in one of the bags. This flask of algae has been gravity fed into the bottom of the bag, and over a period of about a week, that bag will fill on up to here and start harvesting. Yeah, that bag will fill it up right now. There's another one right here started. Let's just kind of crowd on down this way. It's a little kind of got a limited space. Why don't you guys come right up in this area here, so then these guys come on down. Let me move these out of the way here. We can kind of stand back in here. Crowd on down in here best you can. We haven't got much room. But the reason I want to stop here is demonstrate two different ways of growing algae. We talked about these bags over here, which is a continuously flowing system. 24 hours a day, water comes in. 24 hours a day, algae comes out. That algae goes to various parts of the building to feed the adult oysters or clams or the little tiny larvae or the seed. That's one way of growing algae. Another way is these tubes behind me here. You saw the 4-liter flask, or starting a bag over there. We'll dump a 4-liter flask in one of these the same way, but it's only filled about this deep. Tomorrow that's going to get a lot darker, like the ones behind it over there, and we're going to add more water to it. We're going to let it grow about one more day. So it's a day to get like this. We'll add water to it, let it grow another day, and those cells divide in there, get more and more cells. That's all that's going on. And then we're going to take that tube, and we're going to start a bigger tank outside there. These are about 500 liters. We're going to start a 5,000 liter tank out there. One second. We'll use that 5,000 liter tank to start a 20,000 liter tank. And maybe the 20,000 liter to start a 40,000 liter tank. And we'll work our way up. All over a period of about 2 days in the flask room, a couple days here, a couple days there, and a couple days there. So what, 8-10 days later, we have, instead of a little tiny volume like this, we have 20 or 40,000 liters. Question.
What do you do with inside there? What do you do with it?
Tomorrow we're going to add more water to it. It's going to grow more, the cells divide. And then when it gets full, we're going to take this, I'll show you the next step we go to. We're going to pump this into another tank, a bigger tank yet, and let it grow more yet.
The air for the oxygen for the algae?
Yeah, the air you see bubbling in here and in the bags over there is almost, but not quite, just pure air, natural air, but we add a little CO2 to it, carbon dioxide to it, to help keep the pH down. These cell concentrations, the pH start skyrocketing if we don't have the CO2. So that's carefully balanced through some solenoid valves. We're actually going to go in a greenhouse in here. I think I'm just going to open the door. We're not all going to go in there, but we'll go in one of these greenhouses here. So we go from a small tank like that to a bigger tank in here. We'll take a peek in, and we'll walk down to the greenhouse here. We can take a look at some of the bigger tanks yet. So let's take a quick look in here. So this is the next step in the algae. These tanks are filled with water, and we add some nutrients, and then we pump that tube into here and let it grow. There, she got a good view from up on top up there, all right. But that tank closest to you, I think, is just plain old seawater. There's no algae in it yet. So the algae is going to grow out here for about 2 more days. And after 2 days, actually every day, 2 of these tanks are moved on to the next stage. So we started out with actually a little tiny flask like that. We went to a bigger flask like this. We went to those tubes that are about this big around and that tall. Then into one of these tanks. And next we're going to go in the greenhouse behind me here and see bigger tanks yet. All working our way up, working our volume up. So let's go right through the door. Watch your step coming out of here. We're going to go right in that greenhouse door over this way. So this is the next step. Those tanks we just came from are 5,000 liter tanks. These are 20,000 liter tanks. They're quite a lot larger yet. But the same thing is going on. You have natural light coming in, and you have artificial light from the lamps above the tanks. All we're doing is adding more water, more nutrients, more light, and letting the algae grow for a couple more days. And from here, after 2 more days, we can do one of 2 things. We're going to feed it directly to the shellfish, either larvae or the seed or the adults, the broodstock, or we'll take it to one more stage yet. So far you've seen 2 ways of growing algae. That flow-through system where it's 24 hours a day, water comes in and algae comes out. And you've seen this what we call a batch system, where you fill these tanks up, the static tank, let it grow, move it on to the next stage. And outside, I point out a 3rd way of growing algae. I mentioned there's one more way of growing algae. You see the big tanks down below? Those aren't 500 liter or 5,000 liter or 20 or 40,000 liter. Those are 70,000 liter tanks, bigger yet. But a totally different thing going on down there. We're pumping water directly out of the bay. And directly into those tanks down there. Natural light only, no heat, and letting the algae grow whatever's in the bay out there. So it's not a cultured species. Whatever's in the bay, we're letting it grow in these tanks. And we're feeding that to our shellfish. So we don't have real good control over it because there's a lot of different species in there. But it's very nutritious also.
About how many species?
It can be almost a monoculture, or it can have a zoo of dozens of species in there, yeah, depending on what's happening out in the bay out here. And I can't even tell you what's in there right now because I'm not sure, yeah. While we're out here, you guys are talking about animals. Let me move this cover off just a little bit. We'll get it out of the way.
Is there any sea creatures in here?
There's some real small ones in here. We're going to look at some bigger stuff inside, but while we're out here, I'm going to reach my hand down here and see what I come up with. Anybody have any guesses?
Oh, mini fish.
Mini fish. Nothing swimming. And it's not an oyster.
What is it, Jerry?
Bugs.
What you got?
Oh my God.
And it's not a mussel, but that's a very good guess. We do have mussels out here, but this particular one's not a mussel. And it's not a gooey duck. And it's not an oyster.
Shellfish.
It's shellfish. Let me see if you guys can tell me what it is.
Sand.
It looks like sand, doesn't it?
Yes. But it's not actually.
But it's not sand.
It's a worm.
And it looks like a worm because it's sticking together, doesn't it?
It's a worm.
But if you look closely, there's individual little things there.
Oh yeah, I see. I don't see them.
Those are manila clams. They're steamer clams. Anybody have an idea what this thing is?
No, locker. There's a spider on it.
What happens if our power goes out around here?
Generator.
If our power goes out, we haven't got any water pumping in, we haven't got any air, we haven't got any light. Things go downhill really quickly, so that generator will kick on automatically. It can kick on right now if the power went out and keep us with power inside the building. Watch your head on here. We're going to go right back inside again. So what do you see in here? Gooey ducks. How many gooey ducks are in that table?
2.
Are you sure?
Yeah.
I think there's a lot more than 2. Look around.
Look at that. What about those 3? I see it.
Well, that's not a gooey duck, is it? And that's not a gooey duck. And that's not a gooey duck. You guys are looking at clams outside. Here's more manila clam, the same thing, only a little bigger now. You can see them. One second, we'll do that.
Those are stings.
How about that one? What's in there? Why doesn't somebody reach in there and pick a couple of those up? Go ahead.
What is it?
What is that?
Baby gooey duck.
Baby gooey duck. All right. I thought somebody would get it.
Asa, you're picking up gooey duck. There's 200 in there. Oh, I'm not. There's 200 in there.
So they're the same thing.
Where did Asa?
You want to grab that and hold it?
Okay.
Be careful where you point it because it's going to squirt somebody.
What is it? It's a squirt gun.
It's the same thing. You see the little seed over there? That's what it turns into in about 7 years.
It's squirting my paper, Squirt me, Jared. And the squirt gun. Squirt it again. Squirt it again. Squirt it, B. Put it in the water. Jared. Squirt it. Squirt again. Squirt me. Hold at me. Put it in the water. Put it back.
How old is that one there?
That particular one is probably 7 or 8 years old.
It's that one. Can I pick that one up?
You can grab that one if you want.
It's the other one. Grab it, Hannah.
Go ahead.
Right here.
What's up? Is it the bite you?
So we just read today that some ducks are 150 years old. Is that true?
They can get to be that old. And the only reason I know how old these are is these 2 are actually cultured gooey ducks. We have more over there I'll show you in just a minute. I don't know how old they are, but not that old. But they have documented. What they do is they take it in their lab, they take this shell and they cut it this way, and they polish it up and put it under a scope. They can actually count growth rings.
What is it doing? Going to the bathroom, let me get it.
Whether a gooey duck is that big over there, or this big, they still have a foot to dig with. And that's where his foot's at.
Can I hold it? What's this here? It looks like a snake.
Pardon?
What's this, Woody?
What is that thing? Anybody know what those things are?
A baby sea urchin?
Sea urchin.
Can you pick it up?
Be careful if you pick him up because he's going to be pretty spiny. What else do you see in that tank? What else is in there? What's in the other green container over there?
Can I pick it up?
Pick one of those
I
up.
want to touch a gooey duck.
Obviously it's an oyster, but you know what kind of oyster it is?
Is that a gooey duck?
It's actually the only oyster that's native to Washington State.
What are these?
It's a native Olympia oyster.
Oh, I want to touch it.
The other oysters, the 2 big ones right next to that, are Pacific oysters. But they come from Japan.
You're talking too fast. I can't. Yeah. What are those white things on it?
We'll talk about just a second.
What are these things?
Let's go around the table here again. We talked about the clams. We talked about the gooey ducks, the olies, the native Olympia oysters. The 2 big ones are Pacific oysters. How about that shell there? Why don't you pick that shell up? Can you see grab that shell. What's on that shell? What do you see on there? Look on the other side.
What is this stuff?
What are those?
They're not warts.
Like little clams.
Look like little clams, but actually they're little oysters. That's how oysters, I can't say that's how they start out, but that's how they are after they start out. And next to them is,
sea cucumber. Carly, share
you guys saw the little tiny clams outside? You saw the little bigger ones here? There's the adults right there.
I know. 3 babies are on this one. My parents, and then they went to go get oysters, and they dig them up.
Yeah.
After they do it.
They're good to get, aren't they?
In a private, yeah, that's what you have to do. What's this?
What do you see in the bag there? The purple bag? More oysters. That's oyster seed.
Did they get caught? No.
And here, excuse me, here you have a couple of scallops. Anybody know what this guy is?
Let's see. This is a scallop. Weird.
Anybody have an idea what that is?
A rock. Weird.
Looks like a rock. How about the one down there? The same thing.
It looks like a snail.
It is kind of a snail. Oh, it's an abalone.
That thing right there is what is
Sea cucumber.
Sea cucumber.
We're gonna move on, guys.
I didn't get the green duck.
Well, hopefully we have time. We're gonna see more gooey ducks on the other side over here. I'll show you more gooey ducks over here. Hey guys, let's go through the door over this way.
These are questions. Unless someone tells you you can handle them, okay?
Crowd on down. Got limited space. There's a lot of things going on in this particular room for what we can see right here. The tray you guys are looking in is more gooey ducks that we actually harvested yesterday out of some sand. And the top tray and the bottom tray are full of gooey ducks. You can see how many in some of those screens. Those are going to go out to the bay tomorrow and the next day. We haven't talked about the life cycles or spawning the gooey ducks or anything yet. But the gooey ducks are going to start out basically, we saw a couple adults over there. There's more over there too. We'll see more down here. But when I spawn those, right by looking at them, you can't tell if they're a male or a female yet, not until I spawn them. When they do, when they spawn, they're going to be free swimming larvae for about 3 weeks, 3 to 3.5 weeks in the big tanks over here, and some small tanks I'll show you. For 3 weeks, they're swimming around in the water column. After 3 weeks, they go into containers like we're inside over there, right underneath these cardboard over here. In the sand, the larvae stop swimming, they lose their ability to swim, they drop down into the sand and start crawling around. At that time, they're feeding by 2 ways. They're feeding on that single-celled algae through their developing siping. They also stick their foot out like this. They pull their foot back in. Now their foot has little cilia on it, like my arm does, and they actually feed off of that. They feed on bacteria and detritus and various things, and so they're feeding both those ways. So they're going to be swimming for 3 weeks. They're going to be in those down wells, which I didn't open up underneath this cardboard for 3 weeks, about another 4 to 5 weeks to get to this stage. So you got 3, 6 weeks plus another 5 weeks. So 3 months basically, almost 3 months old from spawning. Yeah. From an egg and sperm to that size in the hatchery here. So you can see the gooey ducks. We're going to divide those up tomorrow and split them up before they go out of here. You also see the tank right behind you here. And more shell with actual small oyster set on that. That's some research oysters. Down there by Joy underneath that cardboard, we didn't take a look at that, but that's where we set the swimming larvae and let it settle into sand. You also see these little tiny guys behind me here. We saw those great big, I call them silos or screens outside with the baby clams in them. This is all set up exactly the same way, only at a much smaller scale. We do this for a breeding program to do more research, which these lovely gals are working on back here right now, right? You can explain it in a minute, right? Better than I can. So in these are more, these are all oysters? Kelly, are these all oysters here? Yes. Each one of these is a single oyster family? Yes. From one male and one female in each one of these containers. Little oyster seed. Right there. That's a breeding program working on genetics and things. Can you see them out in there? The main thing is we don't want to be reaching in there and mixing them up because Kelly would be real mad at us, wouldn't you? And Joff would be. Questions where? There's a question.
Are we going to be touching more sea animals?
Are we going to be touching more seed animals? I have more geoducks, adults we're going to see down here. And we're going to be looking at some real small larvae. But if we want to go back to that tank, if we have time, we'll go back to that tank we're at, if you guys want to take a look more at the small seed. Let's go right on through this room into the other room down there.
Why are you growing some of the Olympic oysters?
Oh, it's for the enhancement project for genetic reasons. We're actually working with the Puget Sound Restoration Fund.
Okay,
who
right.
has state funding to work with.
And putting some in Discovery Bay and that.
Yes, this particular group that I didn't point them out over there. We have larvae spawning over there now. I didn't get a chance to point out, but I can point them out in the tank back here. It's actually broodstock adult oysters from Triton Cove down here. Okay. And that are spawned here and can be planted back out in the canal here somewhere, specifically for that.
Okay. What happened this summer when you guys were almost closed to the Vibrio? Was that?
Oh, yeah, it took there's several things that can screw up a shellfish company as far as that part of the company goes. It doesn't affect me here. Other things affect me here that I can't see because I can't grow things. As far as shutting down and selling, you have the Vibrio pyrrhemolyticus. You have the another Vibrio volnificus. Of course, you have PSP, parasitic shellfish poisoning. Those are the three major culprits that will close the area down. And that's why tailors are so diversified.
They don't property areas.
Property areas and species that grow. They go from Canada, Mexico, retail out in Hong Kong, hatch another one just like this in Hawaii, a lot of holdings in BC. They're spread out a lot. That's what keeps them afloat. Otherwise,
anticipating that they could be closed by
and they will be. Who will close? From time to time, Oakland Bay will close down in Shelton, or BC will close down for shellfish poisoning. And it happens. It's part of the game we play.
How many employees are there now with Taylor?
400 and some. Okay. They just purchased Fanny Bay oysters in Fanny Bay, just north of Nanaimo.
Oh, yeah.
And they have 85 employees up there. So that's just, as of last month, that's part of Taylor's now also.
Congratulations.
Big purchase for them, yeah.
Wow.
These actually came from Thorndike Bay just north of us with different age classes. These are probably 4 to 5 years old here. And the UW is actually doing some research work on how much they spawn. And the University of Washington tomorrow, along with the state down here at Point Whitney, will be here tomorrow doing some work.
Can I pick one up?
I'll pick this one up.
We'll pass them around a little bit. Everybody likes gooey ducks.
How is the natural production of gooey duck out in the...
Very spotty. And the way I understand it is the natural beds out there that are commercially harvested, or if they do genetic work on them, they'll find that maybe 20 years ago they had a big set. And very little in between, then another big set, maybe 5 years later, maybe the next year, maybe not for 10 or 20 years again. Conditions have to be just right, and then they'll get a big set.
Look at the tiny one.
If you look back in here,
Can you move, please?
there's even some bigger ones, see? You can pull one of the big ones out if you want.
Excuse me. Please,
Why don't you just pull that one big one up and just pass that big one around. Let's just hold on the one big one up here, because the reason I don't want to disturb these, I'll actually try to spawn them tomorrow down here. There he goes.
Someone pointed it at my face.
You see, he got a little one there too. See how little that one is? You know what that is?
No.
Algae. That's right. See how dark it is? Looks like dark coffee, doesn't it? Good espresso. Whether we're talking about a mussel, which we haven't seen yet, or the geoducks, or the oysters, or the clams, what they all have in common is they swim for a while first, in the larvae stage. And those great big tanks behind the wall over there are larvae tanks. These small tanks right in front of you here are larvae tanks. They swim for different amounts of time, but when they're swimming, they eat. And we now know what they eat, right?
Yeah.
I hope we know what they eat. And lots of algae, different types of algae. We have a lot of different species of algae over there. This particular system is very similar to the algae you saw over there. 24 hours a day, you see water coming in. 24 hours a day, water comes out. And there's a screen in there, looks like this. This is down in that tank. It's got a screen on both sides, so the larvae can't get out of that tank. So the water comes in, water goes out. If you follow that piping, it goes down to a gutter down there, right?
Yeah.
And then it drops in the ditch right underneath your feet. Into a little tank down there. And then it goes to that great big gray thing over there. That's a heat exchanger. It takes the heat out of the water and heats up the incoming water back over here again. So we get the heat back out of that water. And all the times, we're adding food. If you looked in here, you see a lot, it looks like coffee in there. That's more of the algae we grow in the bags over there. So we're recovering the heat. We're taking the algae. We're mixing it into the water over here. Dropping in over there. The larvae stays in the tank because of the stream. The water goes back out. Back in to take the heat out of it again. And then the cold water goes back to the bay again. And that's the whole cycle. That's one way of growing algae, kind of like the larvae, kind of like the algae. You have the flow-through system, or the big tanks over there, a static system.
Take about 2 minutes to write down questions and things that you have seen today. A couple of sketches. A guida, maybe some of the tanks that you saw the algae growing in. What are some pictures you have in your mind that are going to help you remember?